let's talk about constant rate of change and slope. So we've talked about constants a little bit. We're going to look at how we can find the constant rate of change in different tables, graphs, etc. So first off, we are looking at linear equations because linear equations have a constant rate of change. It's going down here at the constant rate. Versus something like this, it's really steep and then it kind of veers off and then it gets steep again. It's not constant how much it's changing. So slope or constant rate of change, they are kind of interchangeable. It is how one value changes in relation to another. The ratio of the y, which is the vertical change, to the x, which is the horizontal change, is what you are looking at when you're finding that rate of change. So if I'm kind of writing it shorthand, I use this delta, that means the change in y over the change in x, okay? So if we were looking at this scenario right here, it's kind of hard to see because it's pretty small, but we are looking at, okay, how much do those, let me highlight it, y values change in relation to the change in x. So finding the slope or constant rate of change from a graph. We use this little kind of term, we say rise over run. A lot of people want to run and then rise, but it's rise first. You have to get up before you go for a run. So what's important is you find two distinct or clear points. You don't want to pick something that could be in the middle of the coordinate grid that we don't have an exact value for. And then we find the rise, so the vertical change over the run, the horizontal change for the points. So if we were looking at this, I'm picking these two distinct points. I could pick these two, I could pick these two, I could pick these two, as long as they're clear points. The closer together, the easier, and I like to work with these positive values here. So I'm just looking at how much does it rise or vertical change, 1, 2, 3, over how much does it change horizontally, 1, 2 to the right. What's important to note is that up is positive, down is negative, left is negative, right is positive. So let's look at these two examples. Again, picking clear, distinct points. I'm going to pick these ones right here. So I'm looking at the rise, which is going up 1, 2, 3. Positive because it's up, and then to the right, which is positive, 1, 2, 3, 4. So our slope, or our constant rate of change, is 3/4. For number 2, you have to be extra careful because this is an actual kind of word problem scenario where the values on your x and y axis don't necessarily go up by 1. So be careful as you're looking at that. So with my 2 points that we've got pointed out here, first off, we're going down, which is negative. And I'm going down 1, 2, 3. Those go off by 1, so that's fine to leave as -3. Over to the right, it's going over 1, 2, 3, but each line represents 10. So it's actually 10, 20, 30. So -3/30, which is going to simplify to -1/10. And what does that mean in this scenario? Well, we're comparing the candle length to the time. So the wax, or the length, decreased by 1 inch every 10 minutes. So those were examples with graphs. Let's look at examples when you are just given 2 points, or a table. You can really do it the same way. Again, pick 2 clear points. If you're given a table, pick 2 out of them. Find the change in the y over the change in x and simplify if need be. What is important is it doesn't matter for like this where we're given 2 points. Doesn't matter which point I start with, just that I'm consistent. So if I start with the y from this point, I have to start for the x from this point. If I started with the y here, I would start with the x here. I always like to start with the bigger number just because then I can stay in the positives, and I like to if I can, but let's see. So we do the y first. So I'm going to start with 6. I'm subtracting the other y of 3. Since I started with 6 for my x, I'm going to start with 4, or sorry, for the y, I'm going to start with 4 for my x. So 4 minus the other x of 2. So 6 minus 3 is 3. 4 minus 2 is 2. So our slope is 3 over 2 because that's simplified. Number 4, again, we've got these 2 points here. We start with the y's. We have 7 and 2. I like to start with the larger y, so I'm going to start with 7. So 7 minus 2. Since I started with 7 for y, I'm going to start with my 3 for x. So 3 minus our other x of 1. 7 minus 2 is 5. 3 minus 1 is 2. So our slope is 5 over 2. And yes, you can leave it improper like that. All right, number 5. We're going to look at kind of a special case scenario for both of these. Again, starting with our y's, you might notice right away that we have the same y. So it doesn't matter which one we start with. Let's look at what happens. We get 9 minus 9. And then now I'm subtracting my x's, 11 minus 7. So 9 minus 9 is 0. 11 minus 7 is 4. Well, that looks weird. 0 over 4. Some people might be like, that's not possible. But if you plugged this into the calculator, 0 divided by 4, you get the answer of 0. It actually works. It makes sense. So our slope is just 0. But let's look at it for number 6. So we've got our y values that I'm going to start with. 8 and 1, so I'm going to do 8 minus 1 over. Now when I look at my x's are the same. So 5 minus 5. So when I do that, 8 minus 1 is 7. 5 minus 5 is 0. That looks weird. Let's test it on the calculator. 7 divided by 0, it says error, because that is not possible. What that would be a vertical slope like this. If you were going skiing on a vertical slope like this, you can't do it. Your body would be undefined, right? So we call this undefined. It's not really a slope. Now let's look at it in the tables. It's the same setup that you would do for the points. We're just going to pick 2 from the table. Again, I like to pick clear points. I'm going to pick whole value points and low numbers because it's easier to work with. So I'm going to pick these 2. No decimals, and they're low numbers. Starting with our y's, I'm going to take my bigger y, so 44 minus 32, over corresponding x is 2 minus 1. When I subtract, I get 12 over 1 for our slope. And what does that mean for the problem? Well, we're talking about cost and hours. So the cost is $12 per hour. All right, number 8. Same thing, just know it goes in the order. X comes first, Y comes second. So this distance on the bottom here is Y. Just like over here, X came first, Y came second. It just went left to right, up to down. So I'm going to pick my 2 lowest points. So I'm going to start with these guys. I like to start with the bigger Y value. So I'm going to do 580 minus 290 over 60 minus 30 for our X. 580 minus 290 is 290 over 60 minus 30 is 30. And when I simplify that, we get 29/3. So what does that mean? We're talking about distance over time. So 29 miles every 3 minutes. All right, last thing we're going to look at is there's 4 different types of slope. So we're going to define those and draw just a general sketch for it. So a slope that looks like this, going up as you go to the right, is positive. If your grade was going up like that, that would be a positive thing. The opposite, if it's going down as you go to the right, that is a negative slope. And then our 2 special scenarios. So if it's just a straight horizontal line like this, if I said, hey, go walk up that hill, you'd be like, that's not a hill, there's no slope. That is our 0 slope. Versus the reverse that I was talking about a second ago, when you've got something straight up and down, that would be impossible to ski. That's not a slope, that's undefined. And that's it.